In the previous part, I showed you how to run this simple propeller simulation. So now it is time to modify it by changing the geometry and the boundary conditions. First of all, as you can see, I have copied the working directory as I showed in the first part. So let's modify a few things. Let's go to constant, try surface. And first of all, we can delete the propeller stem and the propeller tip. We are going to replace the propeller tip with another file, which I have created. I will make sure that you can access this file through the link in the description. I will put it. So yes, let's copy this file, the try surface. And also we can remove the outer cylinder. So now we will actually have a box with a propeller inside and a refined mesh around that cylinder. And so what I'm going to do is I'm going to change the walls from no slip to slip condition. So I will actually define the walls as the inlet condition. So now let's go to system, and we have to change a few things. Yes, let's open the surface extract. And we can remove the propeller stem. And the outer cylinder. We can save the file, and now let's go to the snappy hex mesh. Of course, we remove the propeller stem 1, 2, and 3. And the outer cylinder. Okay, now once we have that done, we can block mesh. And let's run the surface feature extract option. Okay, and now we can create the mesh using the snappy hex mesh. So this will take a moment. I will pause the recording now and get back to you as soon as it's done. So the snappy hex mesh has finished. Now we can continue defining our simulation. So first let's type renumber mesh override. Okay, now let's type. Now we have to define the fields. So let's type topo set dash dict system create inlet outlet. Inlet outlet sets dot topo set dict. Okay, and now we can create the patches. Okay, so the last thing which we have to do before we can run the simulation is to change some of the boundary conditions. So actually first let's go to constant polymesh and let's open the boundary file. And we have the object called walls. And we can simply change the type to patch. And actually the in groups is necessary in our simulation. Let's save it. And now let's change some of the boundary conditions. First, let's open velocity field. Of course, we have to remove the outer cylinder. And we have to define the boundary conditions for walls. So we can define the walls as an inlet. So let's just copy the value from the inlet. And let's repeat this process for all the boundaries. So actually this should be propeller tip. And for walls, we are going to do the same. We are going to use the same condition as for the inlet. Okay, and let's do it for the rest. Okay, and we have to create the zero folder. So we can copy the zero.org. And of course, we have to rename it to 0. I just remembered there is one thing which also must be changed. If you go to the dynamic mesh, So because I'm going to simulate a different type of propeller, I will increase the rotational speed to 200. Of course, you can adjust this value depending on the advance ratio which you want to simulate. You can also change the kinematic viscosity if you want to understand the effect of Reynolds number. So also one more thing before we run the simulation, I have to change the number of subdomains in the decomposed power. I will change it from 4 to 2. And the simulation should be ready to run. Let's decompose power. Okay, and now to run the simulation, we can type mpi run space-np2, or in case you want to use 4 subdomains, you can type 4 in this case. Then space pimplefoam and dash parallel. Okay, so I will pause the recording now and get back when the simulation is finished. The simulation is now finished. The only thing that is left to do is to reconstruct power and to post-process the results.